Hello everyone, let us discuss today the very popular technique called the extracorporeal membrane oxygenation. When you are left with nothing, our ARDS patient is deteriorating, he is desaturating, there is hypoxemia, which is refractory to all available methods in medical science that you have discussed till now. We are left with what you call as extracorporeal membrane oxygenation or ECMO. So today we'll discuss the concept behind it, the idea of ECMO, how it works. So let us discuss. So as you can see here, I have already drawn a pictorial diagram of the system of ECMO. Let us discuss how it works. So here we have the right heart, and to the right heart the superior vena cava brings blood from the upper part of the body, and the inferior vena cava brings blood from the lower part of the body, and they are deposited in the right side of the heart in the right ventricle. And from the right ventricle the blood goes via the pulmonary artery, then it goes to the pulmonary capillaries, and then via pulmonary vein it reaches the left side of the heart. And while it is in the pulmonary capillaries, it is here the gas exchange happens, right? So this is the lungs. So the air from outside comes to the lungs, right, in the alveoli. Then there is gas exchange. The oxygen comes inside, carbon dioxide washes out. Then the oxygenated blood, so you can write it here, this is the deoxygenated blood coming here in a normal person, and that deoxygenated blood is oxygenated here using the lungs. Then the oxygenated blood comes to the left side of the heart, the left ventricle, and from the left ventricle via the aortic distribution the blood goes to the upper extremity and to the lower extremity. Then again it distributes in the capillaries, in the peripheries, then via vein it again comes to the right heart, right? So this is how a normal heart works. Now what happens in ARDS patient, the lungs is not working properly. So lungs now, it cannot maintain the homeostasis that is required to maintain a sustainable life. The lung is bad, it cannot do the function of either oxygenation or ventilation. So now when the lung is not working, the ECMO principle is we have to do the work of ECMO via extracorporeal machine. Extracorporeal means out of the body. So out of the body we create a machine, we put a machine that is called the ECMO machine. This is the ECMO scenario, right? The whole is the ECMO scenario. So if you put an ECMO machine outside of the human body and do what the lung is supposed to do, that means we oxygenate and we ventilate the patient using the ECMO machine. That means we give oxygen to the blood and remove the carbon dioxide from the blood, and we put the oxygenated blood into the right heart, because your left heart is working fine, right? So if you can take out the blood from the body, the deoxygenated blood, and oxygenate it, remove the carbon dioxide outside of the body using a ECMO machine, then put the oxygenated blood into the right heart, from there it can go to the left heart using the same method. Now it is not dependent upon the lungs for a gas exchange. So the left heart now can distribute that oxygenated blood to the whole body. So this is the principle of ECMO machine. So let us write it out, right? So what happens is, from right ventricle via the pulmonary artery blood goes to the capillary, it's called pulmonary capillary. In the pulmonary capillary, here the lung, what it does, it give oxygen to the blood and remove carbon dioxide, right? Then via the pulmonary vein it comes to the left heart, right? And from the left heart it goes to the whole body, the upper body and the lower body, right? And here also in the right ventricle, blood comes from the SBC and the IVC. Now due to some reason the lung is not working. So because the lung is not working, so you are left with a system where although the blood is flowing, it is not able to maintain the homeostasis of oxygenation. There is no maintenance of oxygenation, ventilation. That means oxygen input, carbon dioxide removal, and maintenance of a sustainable pH. So these three things are not maintained now because the lungs is not working. The human think tank now works like that. If the lungs is not working, can you have a machine which can do the work of the lung? And that machine is called the ECMO, right? Which will do the work of lung. Specifically, this is called venous ECMO. What does it mean? That means we take the blood from venous, give the blood to the vein. Because the heart is working, this is working, so we can take the blood from a vein and put the blood to a vein, and that will go via the pulmonary artery, capillary vein to the left heart, which can contract very nicely. So this is called venous ECMO, and it does the work of lung in the outside. The reason why it is called corporeal, extracorporeal, out of the body, right? So this is how the ECMO technique works. Let us see what are the components of ECMO. See, so here, as you have discussed, we will take the blood from one vein and put it on another vein. Because the heart is working, do not have to put it in an artery. You can put it in a vein, and that vein will carry the blood via the right ventricle to the left heart, and it can be distributed. So usually when you do a femoral approach, femoral is one vein, another femoral is another vein. This is a VV ECMO, femoral approach. What you do, let's say we take the deoxygenated blood from the right femoral vein, right, via the right femoral vein, and we use a pump to take the blood out of the vein. Because in the human body, the SBC and IVC, they put the blood in the right heart. There are various mechanisms working. So when you want to bring the same deoxygenated blood to outside, you need a pump. You have to create a negative pressure so that the blood can be sucked out. So this is called a pump, right? So in ECMO machine, the pump works as heart, right? So this is heart. Here we have a motor, that is revolution per minute. It creates a negative pressure so the blood can be sucked out. Principal function of the lung is oxygenation and removal of carbon dioxide. So that you have to do. So there is another machine through which the blood has to go, that is called the oxygenator, right? So this is the oxygenator. It contains a membrane. So this is the membrane, right? The blood will go through this machine, this is called the oxygenator, which contains a membrane through which the diffusion of oxygen and carbon dioxide will take place. So that is from a blender. So we have a blender in which there are air supply and oxygen supply. So it determines the FiO2, how much FiO2 you want to give to our patient. So from here, the oxygen will come and travel through the oxygenator. While it is traveling, and also the blood is traveling, right? So here the gas exchange will happen, right? And the carbon dioxide will be removed and oxygen will be put inside the blood. So the deoxygenated blood or the dark red blood will come here and it will get oxygenated, and bright red blood will come out of the oxygenator, right? Then again, because it is not a human body or a human system which is regulated inside, because the blood is coming to outside, it is in connection with various artificial tubings and all. So it is the intrinsic tendency to clot, right? So we have to use heparin. Heparin is a must. Otherwise the blood will clot on its way, and it can clog the system and decrease the efficiency. So heparin has to be given. So that is the reason why if you cannot give heparin to a patient, that serves as a relative contraindication to ECMO, right? So we have to put heparin into the system so that the blood remains fluid throughout. At the same time, because it's coming outside, it will lose its heat. So we have to use a heat exchanger here before we put the blood again into the body, right? So now the blood is oxygenated, it is heated, it remains clot free because of heparin, and carbon dioxide has been washed out. So now this oxygenated blood, we can put it into the right heart, from where it will go to the left heart using the pulmonary artery, capillary and vein, without needing the work of lung, right? Then the left heart can distribute the oxygenated blood to various organs. So this is how a ECMO work. This is the principle of ECMO machines. So let us see the diagram. So we take the blood, let's say from the right femoral vein, we take the deoxygenated blood. How we will take that? We will take that using a pump. In the pump we have a motor, we set the revolution per minute. So this pump create a negative pressure to suck the blood out of the body. So this works as a heart. Then the blood goes to a oxygenator. In the oxygenator, what happens? Oxygen is put in, carbon dioxide is taken out, right? And from where this oxygen comes? They come from what is called as a blender. There is a air oxygen blender. From here, the oxygen goes as a sweep gas. It is called a sweep gas because it will sweep away the carbon dioxide while oxygenating the blood, right? So from here, and before that, here we have to heparinize. So the blood remains fluid and the system remains patent. Otherwise, there will be thrombus and the system's efficiency will decrease. So once the blood is oxygenated, it will be warmed. Once the blood is oxygenated and warmed, it can put back, we can put it back in the left, via the left femoral vein. It will go to the right heart. From there it will go to the left heart. And here there will be no lung will be there, but it will not do any work because the work has been done by the ECMO machine and the lung is diseased. So it will not work. So we will give time to the lung to recovery. At the same time, we can utilize the oxygenated blood to be supplied to the whole body. Right. So this is how a ECMO circuit works. We take the blood from right femoral vein. If it is a femoral, we can take the blood from a jugular also and put back it via the femoral. Whatever we can do, it's our choice. If you take the blood from a femoral vein via a pump which creates a negative pressure using a motor, now that blood is heparinized and put into the oxygenator where the gas exchange happens and the blender provides the oxygenation or FiO2. This is called the sweep gas, right? And once the oxygenation process and carbon dioxide removal process is done, it is put through a heat exchanger and the heated oxygenated blood is now put into the right heart. From here it goes to the left heart and from there it can be distributed throughout the body. This is how the ECMO machine works. While the ECMO machine works, the purpose is to give the diseased lung a chance to recovery, right? Will give the diseased lung a chance to recovery. So here we can practice what we call as ultra low lung protective ventilation. Because majority of the work is done by the ECMO machine, we can give as little as tidal volume to the lung with a moderate amount of PEEP so that the lung is minimally involved in gas exchange so that there is time for the lung to recover, right? This is the principle of ECMO machine. So in the next class we'll discuss what are the indications of ECMO and what are the things that you have to take care while you put our patient on ECMO. Thank you very much.